You shouldn't be clueless of the car you are driving. Know your car, and save on repair cost. Fix and upgrade your car parts. Drive with clue. Crankshaft. 1. Converts motion into power. The crankshaft converts the up and down motion of the pistons into rotational motion that turns the wheels. 2. Heart of the engine. It is one of the most important engine components because all engine power flows through it. 3. Connected to pistons. Each piston connects to the crankshaft through a connecting rod, transferring combustion force. 4. Made from very strong materials. Crankshafts are usually made from forged steel, cast iron, or billet steel to withstand extreme stress. 5. Rotates at high speed. The crankshaft spins thousands of times per minute, RPM, when the engine is running. 6. Balanced for smooth operation. Counterweights on the crankshaft reduce vibration and help the engine run smoothly. 7. Requires constant lubrication. Engine oil flows through internal oil passages to lubricate crankshaft bearings and prevent wear. 8. Supported by main bearings. The crankshaft is held in place by main bearings inside the engine block. 9. Crankshaft failure is serious. A damaged or broken crankshaft can cause severe engine damage and usually requires a full engine rebuild or replacement. 10. Used to drive other systems. The crankshaft powers other engine components like the timing system, oil pump, and accessory belts. Camshaft. 1. Controls valve timing. The camshaft opens and closes the engine's intake and exhaust valves at the correct time. 2. Works in sync with the crankshaft. The camshaft is synchronized with the crankshaft using a timing belt, chain, or gears. 3. Rotates at half engine speed. In 4-stroke engines, the camshaft rotates once for every 2 rotations of the crankshaft. 4. Has cam lobes. The raised parts called cam lobes push against valves or lifters to control airflow. 5. Affects engine performance. Camshaft design influences power, torque, fuel efficiency, and engine sound. 6. Can be located in different positions. Engines may have OHV, pushrod, SOHC, or DOHC. Camshaft layouts. 7. Made from durable materials. Camshafts are usually made from cast iron, forged steel, or billet steel for strength and wear resistance. 8. Requires proper lubrication. Engine oil reduces friction between cam lobes, lifters, and bearings to prevent wear. 9. Performance camshafts improve output. Aftermarket camshafts can increase horsepower by changing valve lift and duration. 10. Camshaft failure causes engine problems. A worn or damaged camshaft can lead to poor performance, misfires, and engine noise. Timing belt, timing chain. 1. Purpose. The timing belt or timing chain synchronizes the rotation of the crankshaft and camshaft, ensuring engine valves open and close at the correct time. 2. Engine timing control. Proper timing allows fuel and air to enter the cylinders and exhaust gases to exit efficiently, which is essential for smooth engine operation. 3. Timing belt material. Timing belts are usually made of reinforced rubber with strong fibers, like fiberglass or Kevlar, for flexibility and quiet operation. 4. Timing chain material. Timing chains are made of metal links, similar to a bicycle chain, making them stronger and more durable than belts. 5. Noise level. Timing belts run quieter than timing chains, which is why many passenger vehicles use belts. 6. Service life. Timing belts typically need replacement every 60,000, 100,000 miles, 96,000 to 160,000 kilometers, while timing chains are often designed to last the life of the engine. 7. Maintenance needs. Timing belts require regular scheduled replacement, whereas timing chains usually only need attention if they stretch, wear, or cause noise. 8. Interference. Engines. In many engines, if the timing belt or chain fails, the pistons can hit the valves, causing serious engine damage. 9. Lubrication. Timing chains operate inside the engine and are lubricated by engine oil, while timing belts operate dry outside the engine. 10. Performance impact. A worn or stretched timing belt, chain can cause poor engine performance, rough idle, misfires, or even prevent the engine from starting. Valve cover. 1. Purpose. The valve cover seals the top of the cylinder head, protecting the valve train components such as camshafts, valves, and rocker arms. 2. Oil containment. It keeps engine oil inside the engine while the camshaft and valve train are lubricated during operation. 3. Common materials. Valve covers are commonly made from aluminum, steel, or plastic, composite, depending on engine design and weight requirements. 4. Gasket seal. A valve cover gasket sits between the valve cover and cylinder head to prevent oil leaks. 5. Oil leaks. One of the most common engine oil leaks comes from a worn or hardened valve cover gasket. 6. Noise reduction. The valve cover helps reduce engine noise by enclosing moving valve train parts. 7. Crankcase ventilation. Many valve covers house components of the PCV. Positive crankcase ventilation system, allowing harmful gases to escape safely. 8. Maintenance access. Removing the valve cover provides access to valve train components for inspection, adjustment, or repair. 9. Heat resistance. Valve covers are designed to withstand high engine temperatures without warping or cracking. 10. Aesthetic role. In many vehicles, valve covers are visible and may be styled or branded for appearance in the engine bay. Valves, intake and exhaust. 1. Basic function. Valves control the flow of air-fuel mixture into the engine and exhaust gases out of the combustion chamber. 2. Types of valves. Engines use two main types. Intake valves let air and fuel in, and exhaust valves release burned gases. 3. Timing operation. Valves open and close in precise timing with the camshaft and crankshaft to match each engine stroke. 4. High-temperature materials. Valves are made from hardened steel or heat-resistant alloys to withstand extreme combustion temperatures. 5. Size difference. Intake valves are usually larger than exhaust valves to allow maximum air-fuel flow into the cylinder. 6. Valve sealing. When closed, valves must seal tightly against the valve seats to maintain proper compression. 7. Cooling method. Valves are cooled by transferring heat through the valve stem to the cylinder head and engine coolant. 8. Valve springs. Strong valve springs ensure valves close quickly and prevent valve float at high engine speeds. 9. Performance impact. Worn or damaged valves can cause loss of power, poor fuel economy, rough idle, and misfires. 10. Failure consequences. Bent or burned valves, often caused by timing belt chain failure, can result in serious engine damage.